Hello my dear friends, welcome to IMS Gate Academy. I am Sourav Upadhyay and I welcome all of you to this live session of solving HT and IE PYQs. Solving HT and IE PYQs, right. So my dear friends, last week we solved all the GATE 2024 PYQs, and at this point solving PYQs is a very good idea. Why? Because it is going to give you confidence. It is going to tell you that what kind of questions are actually coming in the examination, and more importantly it will help you in revision. At this time you should start remembering all the subjects or whatever subjects we have studied at one single time. So I'll be coming up every now and then with the live sessions where we will be solving the PYQs and some extra questions. That GATE score booster is going to happen in the month of November. So everything is planned, you just need to prepare yourself accordingly, right? So my dear friends, without wasting any time, let us straight away, good evening. So let us straight away get on with the question. So this is an HT question. The question says that a very large metal plate of thickness D and thermal conductivity K is cooled by a stream of air at temperature 300 Kelvin with a heat transfer coefficient H as shown in the figure, right. The center line temperature of the plate is Tp. In which of the following cases can the lumped parameter model be used to study the heat transfer in the metal plate, right. So clearly you can see that this is the diagram that has been given. Thickness is D, and he is asking whether the lumped analysis can be used or not, and these are the options that he has given. Respective values of H, K, D is given. So my dear friends, you know that just a minute, you know that for lumped analysis to be valid, for lumped analysis to be used, the bio number should be less than 0.1. And what is bio number? That is HLC by K. HLC by K value should be less than 0.1. What is H? H is the heat transfer coefficient. What is K? K is the thermal conductivity of the material. Now what is LC? What is LC? LC is the characteristic length. Characteristic length or characteristic dimension. So let me tell you, just let me give you an idea that suppose this is the the plane wall we are taking where heat transfer is in this direction. So when we consider that the convection is flowing on this face of the on only one side of the this wall, the length is L and the conductivity is K. So characteristic length is nothing but volume by surface area. So what is volume? Now volume is A into L, and surface area, where on which side? Surface area, that means on which side only the convection is taking place, that area to be used. So A and A gets cancelled and finally L will be. So thank you Mr. Amit Goyal. Okay. So this is the LC and this is how we get L. But we should always keep in mind that A value is 1 where we should see where the convection is taking place. On this side only one phase convection is taking place, but the question that is given to us, clearly both the sides convection is taking place, and that is why we need to add 2A. We need to add 2A in the in the formula. So what is your LC? LC is volume by your total surface area. So volume is what? Volume is nothing but if you consider A into your D, and what will be the section, section area? On both the sides convection is taking place, so I will be using 2A. So A and A gets cancelled and it will be D by 2. So in this case it will be D by 2, right? So what will be the characteristic length? It will be D by 2. And so if I add over here that what is the bio number in this case, the bio number will be H into D by 2K. So finally what we have to do, we have to find the value of HD by 2K, HD by 2K, and then we have to see that which is coming out to be less than 0.1. So let's say in the first case if I find HD by 2K, so HD by 2K, so H value is 10, D I will put it in meter, so 0.001 by 2 into K value is 100. So this will give me something. For option B, what is HD by 2K? So this is 100 into D value is 1 meter, 2 into 100. So this will give me some value. For C, the option, this is HD by 2K and H value is 100, D value is 0.001 and 2 and K value is 1000. This will give me some value, and finally HD by 2K, H value is 1000, D value is 1 meter and 2 into K value is 1. So this will give me some value. So one by one we are going to check out what are the HD by 2K values. So in the first case it is coming out to be 5 into 0.001 divided by 100. So this is coming out to be 5 into 10 to the power minus 5, which is very much less than 0.1. So yes, it is valid. Lumped analysis is valid in this case. For the second case it is 0.5. So no, it is not valid. It is not less than equal to 0.1. So this is not the answer. B will not be the answer. As for C, we are getting 5 into 10 to the power minus 5. So yes, it is less than 0.1. So yes, this is one of the answers. And as for D, it is coming out to 500. So it is not less than 0.1. So no, D will not be the answer. So in this case, A and C are the correct answers. A and C are the correct answers. So yes, it's an MSQ, and this is your final answer, right? So I hope you got the concept. Lumped analysis is very important. It falls under transient heat conduction, that is the unsteady state, and please do this topic, right? Okay, A and C are your correct options. Let's go ahead. Now another 2-mark question. It's from view factor, and you guys know that view factor is one of the very important. In fact, the entire heat transfer is very important, and you should not leave at this point, right? So what he is saying, a cylindrical rod of length h and diameter d is placed inside a cubic enclosure of side length L, H denotes the inner surface of the cube. The view factor FSS is what? So we have to draw the figure. So just so we will be drawing the cube. So this is the cube of length L, and inside we have to insert a cylinder of dia D. What is saying? Of dia D and length H, and he is asking if I consider this cylinder to be body 1 and if I consider the cube to be body 2, so he is asking what is the value of the view factor F22. He is asking what is the value of the view factor F22. So it's a two body enclosure, and you know that for two body enclosure what do we use? Reciprocity relation. For two body enclosure I use reciprocity relation. In fact, for any body enclosure I can use reciprocity relation. It's just that it should be two bodies, right? Between any two bodies I can use reciprocity relation. So what does it tells? A1 F12 is equal to A2 F21. So 1 I am considering the cylinder and 2 I am considering the cube. So what is the surface area of the cylinder? Surface area of the cylinder will be pi dh, that is the curved surface, plus pi d square by 4, that is the cross sectional area, into twice. This is A1. Now what will be view factor from 1 to 2? Now outer surface, the outer surface area of the cylinder, all the heat will be intercepted by the cube. None of the heat will be intercepted by the cylinder itself. So this value will be 1. What about A2? A2, that means the internal surface area of the cube. So it will be 6L square, and F21 is what we need to find out, right? So F21 will be pi dh plus pi d square by 2 whole divided by 6L square. But he is not asking F21. So you know that for any body I can use this. For body 2 I can use F21 plus F22 is equal to 1, that is the sum of the view factors is equal to 1. Some heat is intercepted by the cylinder and some heat is intercepted by the cube itself. So F21 I know, so I need to find out F22. So F22 will be 1 minus, and this F21, where F21 is F pi dh plus pi d square by 2 divided by 6L square. So this is going to be the final answer, right? So if you check the options, it will be option D, right? So this is your using the reciprocity relation. So you just need to know the fact, and apart from that you will get the answer very easily. Okay, moving on to the next question. Consider a counterflow heat exchanger with the inlet temperatures of two fluids 1 and 2 being T1 is this, T2 is 350, T1 is 300 Kelvin. The heat capacity rates of the two fluid, that means M into specific heat capacity. M, small m into small c, is called capital C1. So it's given C1 is 1000 and C2 is 400 and the effectiveness of the heat exchanger is 0.5. He is asking what is the actual heat transfer rate. He is asking what is the actual heat transfer rate. So my dear friends, again all these are expected topics, and the purpose of solving the PYQs over here is that you get to know that what are the most important topics and that you prepare accordingly. So my dear friends, what is effectiveness? Effectiveness is nothing but the actual heat transfer divided by maximum heat transfer. Actual by maximum. So effectiveness, so what is actual? Actual, you know, he is asking the actual heat transfer. And what is the maximum? Maximum is heat capacity rate of the smaller, that means the smaller value of the heat capacity into, you know, the maximum difference of the temperatures, that is T max, that is inlet, hot fluid inlet. So just a minute. So this is the hot fluid inlet minus the cold fluid inlet, and this is given as 0.5. So all the values are been given to you. So 0.5 is equal to Q actual, what he is asking, and divided by C smaller. So C smaller among the two values is 400. So 400 into what is the inlet of the, you know, hotter fluid. So definitely the higher value, that is 350. And what is the inlet temperature of the colder fluid? That is 300. So what is your Q actual? Your Q actual is 0.5 into 400 into 50. And one thing, this heat capacity is given in terms of watt per Kelvin, but the final answer he is asking in terms of kilowatt. So what I will do, I will just divide it by 1000. I will just divide it by 1000 to make it kilowatt. So what we are getting? So if I substitute the values, we are getting 10 kilowatt. We are getting 10 kilowatt, right? We are getting 10 kilowatt. So, you know, heat exchanger is again very important. Under heat exchangers there are two methods, that is the LMTD method and the effectiveness NTU method, and both the methods are super important. You need to prepare the two methods, you know, in a very neat way. Okay. Moving ahead to the next question. Please read it. So the question says that consider a laterally insulated rod of length L and constant thermal conductivity. Assuming one-dimensional heat conduction in the rod, which one of the following steady-state temperature profiles can occur without the internal heat generation? So he is saying not to consider the internal heat generation. So four figures are there in front of you. So let us see. So you know that one dimensional one dimensional steady state without heat generation. One dimensional steady state without heat generation. So I will straight away take this differential equation d2t by dx square equal to 0. So if you integrate both the sides, so we will get dt by dx is equal to a constant, d of t is equal to c1 d of x. Again if I integrate both the sides, so t is equal to c1x plus c2. So this is the relation that we are getting. What relation? Linear relation. So this is the linear relation. So how does temperature occur with x? Temperature occurs in a linear fashion, and remember what are the assumptions? Steady state without heat generation, one dimensional, k is independent of temperature. All these things we have to assume. So we are getting a linear relationship, and among the the four options, option A and option B are the correct answers. Now linear he has mentioned, so it can be any sort of linear, right? By changing the conditions I can just obtain any of the graph. I can so using the conditions I can just obtain any of the graphs. So option A and option B are the correct options, correct answers, and as I said, MSQs are repeatedly coming, so be prepared or prepare accordingly, as per the the requirements. Fine. So just for your information, GATE 2024 also we saw 2 questions from heat generation. GATE 2024 we saw 2 questions from heat generation. 2023 also there is a question. So automatically you will get to know that what kind of questions he is asking, right? So do prepare this generation topic in a neat way, in a very decent way, so that questions are being asked repeatedly from this portion. Okay. Now let us see the next question. Please go through it. Please go through it. Consider incompressible laminar flow of a constant property Newtonian fluid in an isothermal circular tube. The flow is steady with fully developed temperature and velocity profile. So this is the most important word, fully developed. The Nusselt number for this flow depends on option A, neither the Reynolds number nor the Prandtl number. Option B, both the Reynolds and the Prandtl number. Option C, the Reynolds number but not the Prandtl number, and option D, the Prandtl number but not the Reynolds number. So my dear friends, you know that in convection we study under 2 categories, that is the forced convection and free convection. Under the forced convection we again study under 2 categories, that is the external flow over flat plate and internal flow in the pipe. This is a question from internal flow in the pipe, and the flow can be laminar, the flow can be turbulent. When it is laminar, you know that under under fully developed conditions the Nusselt number is constant, and there are 2 cases again, that is the constant flux and constant wall temperature, and under both the conditions the Nusselt number remains constant. One of the values is 4.36 for constant flux, and for constant wall temperature it is 3.66. It is independent of any of the numbers. It is 4.36 and 3.66. For turbulent, it will be Dittus-Bilter equation that we use. Dittus-Bilter equation. So clearly he has mentioned that the flow is laminar. The flow is laminar. Hello Tarun. Hello. The flow is laminar, and if it was turbulent, then he would have, we have to use the Dittus-Bilter equation, which he will generally give, but in case if you want to remember, you can remember. But it is laminar. In laminar, the Nusselt number is constant. One case 4.36, second case 3.66. So here it neither depends on any of the number. So this is the answer. Option A is the answer. So my dear friends, what I try to say is that do complete your syllabus one time in a comprehensive way, and then most of the questions you will see that whatever you have studied, it is coming from that itself. Just you should know what are the important topics, and question, most expected questions can come from there. Right. So those were the HT questions, and if I try to review, just review the GATE 2023 questions once, what I can say is that questions have come from the lumped analysis, that is conduction. Then the second question came from radiation heat transfer, again an expected important topic. Then the third question has come from the effectiveness of the heat exchanger. One question from heat exchanger will definitely be there, no surprises. And then one of is from heat generation from conduction, that is everyone knows generation is an important topic. And the last question came from convection. So in HT there are 4 chapters. All the 4 chapters, if you do it once neatly, so 6 marks, 6 to 7 marks of HT questions are going to come. So definitely do that. Don't skip. HT is a very scoring subject. Once you do it, you will be able to score a good amount of marks from there. Cost to benefit ratio is good for that subject. Moving ahead, now in 2023 industrial engineering, only 2 questions came. In 2024, see, I'll tell you the pattern. In 2022, close to 7-8 marks subject, 7-8 marks questions came from industrial. In 2023, only 2 questions came. Again in 2024, close to 7-8 marks came. So it's quite fluctuating, and although we cannot just simply tell a number, but if you check, on an average 5 to 6 marks questions will be asked from industrial if you take simply the average, right? So this question is from graphical method, and what he is asking, which one of the following options represents the feasible region of the linear programming model. So these are the equations that he has given, and my dear friends, let me tell you that for this chapter, one thing you need to be very good at, and that is plotting the graph. I'll also tell you, my dear friends, that you may have your own methods for plotting the graph, but I will prefer and I will ask you to follow, I will suggest you to follow this method, which is known as the intercept method. It is called the intercept method. So what is the intercept? Where A is the x-intercept, and B is the y-intercept. So it can be something like, for example, he has given you 2x plus 3y is equal to 12. So I need to plot this on the Cartesian system. So I can write this 2x by 12. I just need to convert in this form. I just need to convert it in this form. So I can write 2x by 12 plus 3y by 12 is equal to 1. So again I can write x by 6 plus y by 4 is equal to 1. So what is the x-intercept? The x-intercept is 6, the y-intercept is 4. So if I try to plot it, so x-intercept is 6, 6 will comes roughly around here, 4 will come roughly around here. So this is 6 comma 0, this is 0 comma 4, this is the y-axis, this is the x-axis, and if you simply try to draw 2 points you have, so you can just draw the straight line. So this will be your straight line, this will be your straight line, right? So again you can have your own methods, but I would suggest you that follow intercept method for plotting the straight lines, right? So coming to this question, he has given 1, 2, 3, 4, 5 inequations. Now you know that inequations gives you region, right? So equation, that means it's a single line, but if I convert that in equation, it will give you region. So here are the equations, and he has already plotted, but he has not mentioned which one is which. So you have to plot. Now this is a 1 mark question, but you have to do a lot of work to get that 1 mark. So 1, 2, 3, 4, 5. So equations are there. So for example, sorry, not 5, only 4 equations there. First one is the objective function. First one is the objective function. Objective function. Okay. So x1 is less than 45. So this will be that line, x1 is equal to 45. If I just see and try to guess, x2 is less than 50. So this horizontal line x2 is that 50 line. This is also done. Now 2 lines are there. Which one is what? So if I try to convert x1 by 60, yes, plus x2 by 60 greater than equal to 1. So 60, 60 will, this is that line 60, 60, yes. And the last one is x1 by 750 by, that is 30, plus x2 by 750, that is 150. No, 60, 60 is this one. Yes, 60, 60 is this one. And 30 and 150, 30 and 150 less than equal to 1. So 30 and 150 is this one. That means equation 4, this is that equation 4, and equation 3, this is that equation 3. Equation 3 is asking you to be, it's not containing the origin, it's not containing the origin. So he's saying you, he's pointing out to the upper part of the region, and the last equation is saying you, it's containing the origin, that is is asking you to come towards the origin. So this line is asking you to come towards the origin. x1 is less than 50, so this one is trying to point out in this direction, and x2 is less than 50, he is saying you to come in the downward direction. So without plotting the lines, separately, from just by seeing itself, we can get the answer. Yes, without plotting the entire line, just by the knowledge of this intercept, you can just guess that which line is what, and if you look at closely, then you can very easily tell that this is the shaded region. This is the shaded region, right? So this region is Q, this region is Q. So what is your answer? Region Q is the answer. Region Q is the answer, right? So you clearly saw that just without plotting the individual lines, we are able to guess the answer. So as I said, graphical method, industrial engineering as a whole is a very important subject if you want to get some easy marks. If you don't want to get some easy marks, you can consider it skipping, but I know that will not be the case. So do complete each and every topic from this subject. It will get you some easy marks. HT and IE, HT and IE. Okay. And I have just plotted all the lines. I have just showed you over here, and I have just drawn it, and just this is the region that we are talking about. This is the region that we are talking about. So I have drawn it and I have just snipped it. Okay. Okay. Anyway, moving ahead to the next question. Again, I told you that only 2 questions came from industrial in GATE 2023, and what this question is saying, with reference to the EOQ model, which one of the options is correct? Now before going to the question, let me tell you that EOQ inventory is very, very important, my dear friends. Yes, these are some of the topics which are as important as your first law, second law, right? So please do read these topics at least once. Which one of the options is correct? So in the next page he has given the options, that curve P1 is this, curve P2 is this, curve P. Okay. So respective curve name he is asking, and you know that, my dear friends, if I ask you basic EOQ model, if I say what is the ordering cost, what is the ordering cost? So ordering cost is number of orders into ordering cost per order. Number of orders is the annual demand by the quantity that is ordered, D by Q into C naught. So ordering cost. So if you try to see what is the relation of ordering cost with respect to the quantity, it is inversely proportional. It is inversely proportional. So which graph is there for inversely proportional? Curve P3. So curve P3 is saying that it is the ordering cost. Now what about the setup cost? Holding cost. So holding cost is nothing but average inventory into the cost of holding per unit per item. So average inventory is Q by 2 into CH. So clearly you can see that holding cost is proportional to Q. Holding cost is proportional to Q. So it will be a straight line. So curve P2 is saying that it is the holding cost. I think in the option he is given setup cost. So ordering, and you know that ordering cost and setup cost are more or less behaves in a same way, right? So these two will be same. Now curve P1, this is one curve, this is another curve. So the red one curve is the curve of total variable cost, or the total cost. You can say that curve P1 is the curve for total cost. Total cost, right? You know that these curves, wherever they intersect, that point is nothing but the EOQ point. The point is nothing but the EOQ point. So all these concepts you know already. So this curve P1 is the total, and this curve, that is the green color curve, which is there and it is in the horizontal, way, that is the production cost. That means it is not dependent on the quantity that you are ordering. That cost is independent of the quantity that we are ordering. So that is the production cost. So curve P1 total cost, P1 curve is the total cost, yes. Curve P2 is the holding cost, curve P2 is the holding cost, correct. Curve P3 is the setup cost. I told you already that setup cost and ordering cost behaves in the same way, and curve 4 is the production cost, which is independent of the quantity that is ordered, right. So option A is your correct answer. Option A is your correct answer. So my dear friends, previous Sunday we discussed all the GATE 2024 questions, and today we are discussing the GATE 2023 HT plus IE questions. Tomorrow I plan to come up with thermodynamics questions, and I will focus on the piston cylinder questions, right. And you know that how much of an important that concept is piston cylinder, right. So I can say that previous 4-5 years, almost 4 to 5 questions, that is almost every year one question of piston cylinder has come, whether it's for 1 mark or 2 mark, right. So as I said that now is a very important time that you should start revising whatever you have learnt, and if not, then try to complete as early as possible. You should not delay much, and because by December you need to complete your subjects, and then you have to attempt the test series also in January month at least. So we will be coming with the PYQs every now and then. Along with it, GATE score booster sessions will also be coming, so in the month of November. So please stay tuned to that, and I personally will be coming weekly once or twice with the questions itself, right. Already I have taught the concepts, the most important concepts you can check out in the playlist, and now I will be focusing mostly on the questions. Okay. So my dear friends, these are our program features. In case you want to join, you can consider it's a 800 plus hours of live classes, theory book, exercise book you will be getting, and most importantly my dear friends, you will be getting GATE question bank of your core subject. Along with it, another book of aptitude and engineering mathematics, a separate book you will be getting, where there will be questions of all the branches, right. So 2 GQBs you will be getting. In case you want to interact with your faculty, you can use this feature where you will be having 12 one-to-one mentorship sessions, where the faculty mentor will help you to strategize your sessions, whichever suits you in the best way. 130 plus online test series, test and video solutions you will be getting, and much more. So you can consider contacting on this number, right. And in case you can join our Telegram group as well, where you will be getting free YT lectures, lecture PDFs, important updates which is related to seminar or webinar, PSU and other government job notifications, expert sessions, and daily quiz, and much more, right. So I hope you are liking the sessions. In case you have any doubt regarding the questions, you can comment on my session, and I will be replying it personally. And in case you have some another separate demand for any special topic, so I can come up with that also, but you need to let me know, right. So today we stop over here. Tomorrow again I am going to come up with the PYQs of thermo, and my focus will be towards piston cylinder questions. Whatever last few years questions have come, that I will be trying to take, right. So do well, prepare well, revise well, don't waste your time. This is a very critical time. It is a make or break situation for you guys. So do study well, we will be with you always, right. So let's end the session on this note. Take care, God bless.